problems from the homework together, worksheet A. Number 1, 4, 6, and 8. So let's look at number 1 together. So the first step in factoring is always GCF, greatest common factor, right? So look at just the numbers. Do we have a GCF? 1, 2, and 35. What is their GCF? What's the biggest number that you could divide into all of them? It's 1, right? Okay. Can I take out an X? No. How come?
Yeah, that's one.
Good, because one of them doesn't have an X. That's minus 35. That one doesn't have an X. You can only bring out an X if it's in every single term, right, Abner? Okay, so now I have 1, 2, 3 terms. This is an AM situation, right? So I need to find two numbers that multiply to give me negative 35 and adds to give me a positive 2. Yeah.
Positive 7 and negative 5.
Good. Positive 7 and negative 5. So since this is just a plain old x squared, I can go straight into my double parentheses. And then it's x, what, 7?
What?
What's 7?
7.
Plus 7. That's a positive 7. And then x, what?
Minus 5.
Good. And that's it. That's all you're doing with this one. Okay? Let's look at number 4. Number 4, we have 15x plus 6. All right, this is not a trinomial, so it's not the AM way, right? Okay, so I need to look for the GCF. 15 and 6, guys, what is the biggest number that can divide evenly into both 15 and 6? 3. And if you don't remember, if you having trouble with that, go to math, number, GCD, 15 comma 6. Right? And then you get 3. Same thing. Okay? So 3. Can I take an X out? No, because 6 doesn't have an X, right? Thank you. Alright, so then 3, and I have to open parentheses. Now you gotta take that GCF and you have to divide it over everything. So guys, what is 15x divided by 3? 5x. Good. 5x. And what is 6 divided by 3? 2. And that's it. You can't do AM because you only have 2 terms. So it's 3 times 5x plus 2. Okay? Questions about this? Alright, so let's look at number 6. So number 6, what is it starting with?
Negative.
Negative, so that means you need to bring the negative out. Now, just the numbers, I have a 6, a 3, and a 3. What is the biggest number that can go divide evenly into all of them?
3.
3. Alright, so I got 3. Now, can I take out an X?
Yeah.
Yeah. They all have an X. But which one is the smallest X?
X squared.
X squared. So the smallest one comes out. And then I have to open my parentheses. What do I do with that GCF? Good. Thank you, Timon. Divide it. So guys, just the numbers. Negative 6 divided by negative 3 gives me what? Negative 6 divided by negative 3.
2.
2. And then think about this. You have 7 x's on the top, and you have 2 on the bottom. How many are left? It's 7 on the top and 2 on the bottom. But those 2 cancel out, yeah. So 2x to the 5th. Right? Look at the next one. Positive 3 x to the 4th divided by a negative 3x squared. What's a positive 3
1.
divided by negative 3?
It should be 1.
What kind of 1?
Positive.
Oh,
Or negative 1.
yeah, because what? Positive divided by negative gives me negative. Negative 1, what? How many x's are left?
2.
Yeah, so can I just say negative x squared?
Yeah.
No. And then look at that last one. A negative 3x squared divided by negative 3x squared gives me what?
1.
Positive 1. Good. And there you go. You know you can't do AM with this because that says x to the 5th. Right?
Yeah.
We can only do AM with the, for now, x squared.
I mean, do you have to do AM or you can leave it like that?
No, this one you can't.
Oh.
You can't because it's x to the 5th. Normally with the AMs, we're right now just doing the x squared.
But if it's square, is it optional or you must do it AM?
You must do it to see if it works. But like, then that's a good way to kind of transition into number 8. Number 8, we have x squared minus 2x minus 9. So there's no GCF. This looks like it should be AM, right? Okay, so let's do that. Let's try AM. So I need two numbers that multiply to give me what? What's my M number? Negative 9. And adds to give me, what's my A number? Negative 2. Okay. What two numbers multiply to give me negative 9? I can give you one. Negative 9 and 1. Right. What else? Negative 3 and 3, right? But guys, is there any combination that's going to add to give you a negative 2? No. So, can you AM this? No. Can you even GCF it? No. So this one is a prime. You can't do anything to it that is a prime. Alright? Alright. Alright guys, so today we're going to talk about factoring binomials. And what is a binomial? Well, if a trinomial has 3 terms, then a binomial has how many? Huh? 2. Because a tri, is like tricycle has 3 wheels, and bicycle has 2 wheels. Binomial has 2 terms. Okay? So all the factoring we're doing today is for 2 terms. And remember, the first rule of factoring is what? It's always the first step. 3 letters. Good. GCF. Remember, the first rule of factoring, the first step is GCF. All right. So, okay, so with binomials, you can always do just GCF, or you can take it a step further, and you can do something called difference of squares. So, tell me guys, let's go over this. 3 things that are needed to use this method. First of all, you gotta have 2 terms. Only 2 terms. When you hear the name difference of squares, difference, what do you think? Yeah. In terms of math, what is difference? What does difference mean when you subtract? Good. So it must be subtracting. If it's adding, you can't use this dose way. All right? Okay. Now, of squares, well, they have to be perfect squares. All Alright, so if you took that number and you did the square root, it better be a nice, pretty whole number. Okay? So you can only use difference of squares or dose when you have two terms, they're subtracting, and they're all perfect squares. Alright, so what do we do? Well, I call this dose because that's difference of squares. Okay? Alright, so if I call it dose, you guys are going to know what I mean. So, what do we do? Well, you know what? That D stands for double parentheses. Okay? So we're going to have double parentheses, just like this. Okay? The O is for opposite signs. So one is plus and one is minus. Okay? And S. Well, with this, then what we're doing is we're going to square root. So square root. Okay? Alright, so what does that mean? Well, let's put it all together. X squared minus 25. Is it two terms? Yes. Is it subtract?
Yeah.
Yes. Are these both perfect squares? Yes. Okay. So I can use those. So I have double parentheses. Right? Opposite signs. One is plus, one is minus. Okay. And then I'm going to square root both terms. So let's see. Square root of x squared is what? Those cancel out. You get x. Alright? And that goes in the first spot because this was the first term. Does that make sense? And then 25. Yeah. Square root of 25 equals 5. And that was in the second spot, so it goes in the second spot. There we go. You factored it. It's x plus 5 times x minus 5. Yeah? And if you FOIL or double distribute that, then your x term, your middle term, it becomes a 0x. They actually cancel out. So then you should get x squared minus 25. Okay? Here's another trick for you. In order to check this to make sure that I did this right. Okay? That's what I'm going to do. And you can always do this when you factor. Alright? Go into y equals. I'm going to put in x squared minus 25. I'm going to graph it. I don't care, like, you know, oh, where's the vertex? I'm not worried about that. I just want to see what this looks like, right? This was my original problem. Now I'm going to go back into y equals. And then the second one, I'm going to put in my factored form. And you can do this with any of the factor stuff. Right? If I factor that correctly, when I go to graph, it should only look like one graph, right? They should be the same thing. Do you agree? So perfect. Okay, then I know that I factored this right. If you did this and you got another graph, like say we forgot about the opposite signs and we made them both minus. Well, there's my original problem in blue. Oh no, there's my factored form. That's how I would know, oops, I have two graphs, I didn't do that one right. Does that make sense? Okay, so let's go back to this. Let's try another example. Example 1, x squared minus 49. Do I have two terms? Yes. Are they subtract? Yes. Are they both perfect squares? Yes. Good. So double parentheses, opposite signs. Guys, what's the square root of x squared?
X.
X. So that goes in the first one. What's the square root of 49?
7.
7. And that's also in the calculator too. Does anyone need to see where to get square root in the calculator? Oh, okay. Alright. And that's it. That's your factor form. Okay, let's look at example 2. Do I have two terms? Is it subtract? Yeah. You know what though? I have a number 4 in front. 4 and 81. Is there a GCF? Check it on your calculator. Go to math number GCD. Tell me, 4 comma 81. Right above the 7.
4.
Mm-hmm. It's 1. Okay. Well then, is 4 a perfect square? Is x squared a perfect square? Yeah. Is 81 a perfect square? Yeah, right? Do you guys understand what I'm saying when I ask if it's a perfect square? Not really? So you remember how we did the perfect squares on our little sheet? So what is 2 squared? 4. Okay, so 4 is a perfect square because square root of 4 equals 2. You know what I mean? Like, you could say a number squared gives me 4, right? Here's the thing. You can also do this. Square root 4. You get a nice pretty number. Then it's a perfect square, okay? What about 3? Square root of 3. Is that a perfect square? No, because it gives you a decimal. We don't want decimals. Alright? Okay, so alright, this is dose. Do my double parentheses, opposite signs. Guys, what is the square root of 4x squared? What's the square root of 4? We just said, what's the square root of 4? 2. And what's the square root of x squared? Just x. These have to go together in the first term because the 4x squared is connected together in the first term. Does that make sense? And you need to square root the number. Okay? The square root of 4x squared is 2x. Yeah? What's the square root of 81? My second term. 9. Okay, so then that goes in the second term. Alright? Questions about that? Okay. Yeah? Alright, and then we'll try the next one. Look at number 3. Do I have two terms? Yeah. Is it a difference? Is it subtracting?
No, I do.
Number 3! Number 3, it's not subtracting, right?
Yeah.
Everything is a perfect square, and there are two terms, but it's not a difference. Is there GCF? Just 1, right? So we don't count that. So then, can I do anything with this? Can I dose this? No. So you know what? This is a prime. should be a dose. There's no GCF, but it's plus, then it's a prime. Can't do anything to it. Let's look at example 4. 2x squared minus 50. I have two terms. It's subtract, but I know that 2 is not a perfect square. Put in square root of 2. Not good, right? Not pretty. So let's look at 2 and 50. Do they have a GCF? Oh, what is it? What's the biggest number that can divide evenly into 2 and 50? Or you could go into math, number, GCD. 2. So that means we gotta take the 2 out. I can't take out an x, right? Because that minus 50 doesn't have an x. Divide them both by 2. What is 2x squared divided by 2? X squared, I think. What is negative 50 divided by 2?
25.
Huh?
25.
Negative 20. Now, remember, the GCF just waits. Hold up. Now, inside the parentheses, x squared minus 25. Can I do dose there? I have two terms. They're subtracting.
Yeah.
Is 25 a perfect square? Yeah. So I can go to, yeah, x plus 5, x minus 5. Don't forget to bring down your 2, your GCF. Okay? All right, look at example 5. Example 5, I have two terms, but it says x to the third. Remember, dose should be x to the second, right? Well, does this one have a GCF? Can I take something out of both of them?
1.
1 and 1. What else do they both have?
3.
Not 3, because it's 1 and 9, so the number is 1. What do they both have? An x, right?
Yeah.
But which x comes out? X to the third or just a plain old x?
Plain X.
Plain old x. So that means you divide everyone by plain old x. So then if you have x cubed divided by x, how many x's do you have left over? Square. Good. Because you have 1, 2, 3 on top and you have 1 on the bottom. Well, then that means you have 2 left over, right? Minus, what's 9x divided by x? Just a 9. Now, can you dose the inside of the parentheses? Yeah. Good. You could bring down that GCF at x. Now you have your double parentheses, opposite signs, x plus 3, x minus 3, right? Square root of 9 is 3. Okay? All right, try example 6. See if they have a GCF. And if not, square root both of them. All right, I want you guys to try this one. So this one, you go straight into dose because their GCF is 1. So it should be 13x plus 14 and minus 14. Yeah? Because 169, square root of 169 is 13, right? And since that one is tied to that x squared, you got to keep them with the x. Are we okay with that? All right. Okay, so now we're going to, oh, actually, you know what? Before we do this, I'm going to give you guys some practice. Let's try these practice problems. And you can write them down anywhere. You can put them on the back of your assignment sheet, or you could put them like sideways right on that same page. You would do it on the back of the perfect squares and cubes, whatever you want. Alright, so try these three, please. Okay, so number one, 4x squared minus 9. There's no GCF, but we can do dose. 2x plus 3 and 2x minus 3. Do we agree? Alright. B. Well, 2 is not a perfect square, and 18 is not a perfect square, but there is a GCF. 2. So then now I have x squared minus 9, right? And x squared minus 9 is dose. And so we should have 2 times x plus 3 times x minus 3. Yes? Okay. And then C. X cubed plus 25x. Guys, there's a GCF here. What is it? X. Good. Remember, sometimes the GCF is not a number. It can just be the variable. So x squared plus 25. Can I do dose inside the parentheses? Ethan, can I do a dose here? Can I keep going?
Yeah.
Yeah?
That's an X squared.
It does have an x squared, but it's not negative. It's not subtract. It's a plus, right? So you have to stop. You can't do dose anymore, and so that's it. Okay? Questions about these? Alright, so now let's go to the back. So with binomials, we just learned how to do the difference of squares dose method. Now we're going to talk about the sum and difference of cubes, which I call the SOAP method. Okay? So 2 things in order to use this method. Alright. You can have add or subtract. Right? This one doesn't have to be just subtract, it could be add too. And obviously they have to be 2 terms, right? We're only talking about the 2-term binomial factoring right now. And the second thing is they have to be perfect cubes. Alright? So if you guys look at your perfect cubes list, what is the cube root of 27? 3, right? 3 cubed gives me 27, right? Look on your list again. What is the cube root of 216? 6. Good. What is the cube root of 8? 2. Does that make sense? What's the cube root of 1,000? 10. Good. All right. So what do we do? Well, this is called the SOAP way because that is what the signs are. This has a specific pattern. We have a 2 and a 3 parentheses. Okay? I guess I could have made my 2 just a little bit longer, but alright, it's okay. We have a 2 and a 3. Here's what happens inside the 2. Cube root. Cube root the first one, cube root the second one. Cube root both of them, okay? And then in your 3, in that first one, you want to square, not square root, square your first one. Okay, that means you're going to multiply it by itself. And in the middle, you're going to multiply both of them. Okay, multiply both in the middle one. And then the last one, you're going to square your second one. Second term. Okay? What?
So in the multiply brackets, you're going to multiplication sign. In the blank.
No, you just do multiply them. Well, here's the thing. Tom is like, where are all the signs? Right? Where are all the signs? We put the signs in last, and we're going to use something called so. Same. That's that S. The O is opposite. And the AP from the soap is always positive. Or you know what? I'm just going to put a plus sign. Always plus. Okay? Same, opposite, always plus. Okay? Alright, so then let's look at x cubed minus 8. Let's try this thing. X cubed, is that a perfect cube? Yeah, it's x, right? Cube root of x cubed. These cancel out, it's just x. Okay? What's the cube root of 8? 2. Alright, so we can use the soap way. Let's set up our 2 and the 3. 1, 2, 1, 2, 3. Okay? So in the first one, I already gave you this one. What's the cube root of x cubed? What? X. Right? And you guys just told me, what's the cube root of 8?
2.
2. Okay. If you fill in that small parentheses, you could fill in the big one. In this first one, you got to square your first. You got to square this guy. What is it? What is that times itself?
X squared.
X squared. Okay. And then in the middle, you got to multiply both of them together. What is this times that? You got 2x. Right? And then in the last one, you need to square the second. This guy multiply itself. What is that? What is 2 times 2? 4. Okay, so we fill that in. Where are the signs? Now we have to do so. Same as your original sign, which is what? Minus, right? So same, what's the opposite? And then always plus. There we go. Unfortunately, you have to memorize this. Okay? But it'll get easier with practice. Let's try some more. Example 1 says x cubed plus 64. It gives you all the things up there, but we can write out our 2 and the 3. Right? Guys, what's the cube root of x cubed? X. Good. So that goes in the first one. What's the cube root of 64? It's on that little cheat sheet. 4. Thank you. All right, so we have our small parentheses. Let's look at our big parentheses. The first one, you got to square the first guy. What is it? X squared. In the middle, 4x, because you got to multiply them. And then last one. Good, you square the second one. Good job. Now, so, same, opposite, and then always plus. Yep. There we go. Good. Let's try example 2 then. Yeah? Example 2, 125 and 1. Do they have a GCF? What would the GCF be? Just be 1. We don't bother with the 1, right? So, oh, and yours, does it say, I'm sorry, it says x cubed, it says x squared, doesn't it? Can we change that little 2 to a 3? Sorry, I don't know what happened there. Okay, so let's do soap with this one. Because I'm getting familiar with my perfect cubes, and I know that these are all perfect cubes. Guys, what's the cube root of 125x cubed? There's a number with that x. Good. Cube root of 125 is 5. Cube root of x cubed is x. So in this first space, you have to put 5x. Don't separate the 5 and the x. Keep them together. Look at the second guy. What's the cube root of 1? 1. 1 goes there. Yeah? Alright, so in this first one, is the first one squared? That means the first one multiply itself, right? So what is 5x times 5x? Oh, times, what's 5 times 5? Good. 25x squared. Be careful of that, okay? Yeah, Kimberly, good. And then in the middle, we need to multiply. So what is 5x times 1? 5x. And then what goes in the last one? 1, because it's your second one squared, so it multiplies itself, which is 1, right? And then so, same, right, minus, opposite, always plus. And we're done. Which one do you guys like better, those or soap? You like those?
Yeah.
Yeah, those is easier, isn't it? Yeah, I like soap. I don't know, I'm just, Okay, so let's look at example 3. Oh, wait a minute, guys. That one says x to the 4th. So, and I know I can't do dose because it's plus, right? Maybe this is a soap. Let's check for a GCF. So if I have 2 and 2,000, what's my GCF? 2, and then good. So 2 comes out, and you have x to the 4th, and you have an x, right? So Kevin said x needs to come out. Good. Let's divide everyone by 2x, and let's see what we get. What do we get? What is 2x to the 4th divided by 2x? X. You had 4, and then on the bottom you have 1. 3. X cubed. Yup. Ethan, I totally knew what you were saying. I was trying to help you work through it. X cubed. And what is 2,000x divided by 2x? Huh? 1,000. Yeah, because the x's cancel out, right? So plus 1,000. Okay, so now can I do soap? Is 1,000 a perfect cube? Yeah. Okay, so let's do soap. There's a 2 and a 3. And you know what? You can bring down your 2x now so you don't forget it later. Because that 2x doesn't do anything anyway, right? Just waits. What goes in the first one? Just x. What goes in the second one? Huh? 10? Yeah. What's the cube root of 1,000 is 10, right? What goes here? X what? Squared. What goes here? 10x. And what goes here? 100. Now, tell me about the signs. Same. Opposite. Always plus. Okay? Is this okay? Is anyone completely lost? Alright, so let's try the next two. Guys, x cubed minus 3. Huh. Is 3 a perfect cube? No, right? Is there a GCF? No? Can you do anything else with this? No, this is prime. Okay? Alright, I want you guys to try example 5, please. Okay, guys. 512 and 27, do they have a GCF? No, their GCF is 1. But it's an x cubed. Is 512 a perfect cube? Yes, Kevin's saying yes. Is 27 a perfect cube?
Yes.
Yes. Oh my goodness, so they're all perfect cubes. That means I can do the SOAP way. Because I also have 2 terms, right? What is the cube root of 512 x cubed? 8x, good job. What's the cube root of 27? 3. So guys, what goes in this first spot right here? What is it? 64 x squared. Good. Great job, guys. So what goes in this middle one right here? What is 8x times 3? 24x. Good. What goes in this last one? Huh? 9. You know? What are my signs? Same.
Subtract.
Opposite. Always plus. Good. Alright, so next class. You have a mini quiz. And that's basically on what we did today and last class. So basically everything on homework A and B, those things, okay, those topics. I'm also going to give you your Unit 1B test back, okay? Your test corrections. Alright, so Unit 1B test, I'm giving those back to you. The corrections. They're going to be due, if you have me on a red day, hold on, what is today?
Right there. 12.
Today's the 12th? 4, 6, okay. Then it's due on October 26th. If you have me on a black day, then it's due October 25th.